Hello and welcome back to another video. In this problem, we're asked to prove the statement using the precise definition of a limit. So the precise definition of a limit states that the limit as x approaches a of f of x equals L if for every positive number that you pick, which we call epsilon, there's an associated positive delta such that 0 is less than the absolute value of x minus a is less than delta. If this is true, then the absolute value of f of x minus L is less than epsilon, right? So there is, for any epsilon, there's a delta for which plugging in this for delta means this is true for epsilon. So plugging in for our particular values for this, a is the value which x is approaching, so that's -2. So 0 is less than the absolute value of x minus -2 is plus 2, is less than delta. Saying that the absolute value of x plus 2 is greater than 0 right here means that x plus 2 is not equal to 0. This is also saying that this is not equal to any of the negative numbers, but we already knew that because it's an absolute value, so we can simply say that x is not equal to -2. However, this is the limit as x approaches -2, so we don't actually care what happens at -2, so we can ignore this part of the inequality. Simply say that the absolute value of x plus 2 is less than delta. If this is true, then f of x is x squared minus 1, it's the function there. L is the value of the limit, so that's 3 minus 3 is less than epsilon. Therefore, x squared minus 4 is less than epsilon. We want to factor this, so x squared minus 4, this is x squared minus 2 squared, difference of squares. This is x plus 2 times x minus 2, and the absolute value of this is less than epsilon. If we have the product of two things that are inside of an absolute value, we can take them out into their separate absolute values, just like so. And then we can say, okay, we want to get a relationship between delta and epsilon. And so we have x plus 2 is less than delta, we have x plus 2 is less than epsilon, but we have this thing attached. And we can't just divide out by x minus 2 because then you have x's on both sides. So what we're going to say is we're going to pick some positive number c such that c is greater than the absolute value of x plus 2, right? And we are going to do that so that when we say that the value of c is greater than the value of this particular function, right? And we're actually going to need c to be greater than the absolute value of x plus 2. Then when we multiply this by x minus 2, we get x minus 2 times x plus 2 is less than c times x minus 2. And therefore we can say that I did mess it up, and I was right to make that change. C is greater than the absolute value of x minus 2, and therefore if we take x minus 2 and c in this inequality, right, the reason I chose this and the reason why I was getting confused over this is because what we want to do is to multiply both of these sides by x plus 2, which we do, and therefore we can say that c times x plus 2 is less than epsilon, because x minus 2 times x plus 2 is less than epsilon, and it's less than c times x plus 2. We can say that this is true by saying that x plus 2 is less than epsilon over c. And therefore, if x plus 2 is less than epsilon over c, and it's less than delta, then we can say that delta equals epsilon over c. And so therefore, we have a relationship where for any epsilon that we pick, we have a delta for which we can say that this is true, and therefore the limit is true. However, this isn't the most helpful thing in the world because we don't know what c is. So what we're going to do is we're going to pick a particular delta and say, okay, absolute value of x plus 2, right? This is less than 1. Let's just say delta is 1. Therefore, x plus 2, this is less than 1 and greater than -1. And if we subtract 4 from both sides, then we can see that x plus 2 minus 4 is x minus 2. This is less than -3, and it's greater than -5. And therefore, the absolute value of x minus 2 is less than 5, right? The biggest absolute value that you'll see in this range is of -5 over here, which has an absolute value of 5. So all of the absolute values are less than 5. If the absolute value of x minus 2 is less than 5, and the absolute value of x minus 2 is less than c, then a valid c that we could choose for this particular delta is that c is equal to 5. Therefore, delta is equal to epsilon over 5 for the given delta that we had of delta over 1. So this statement has provided us with two different deltas. So how do we know which one to choose? Well, what we have to do is to pick the more restrictive value, the smaller of the two values. And so we denote that by saying delta equals the minimum of 1 and epsilon over 5. Because we don't know what epsilon is, right? Because we could pick any epsilon. If epsilon over 5 is bigger than 1, then the value is just 1. And if it's not, then we go with epsilon over 5. But we have to pick the smaller of these two values to get the more restrictive definition of delta that allows for this to be true and cause this to be true. So this is our delta, which proves that, okay, for any epsilon we have a delta, and therefore this limit is true.